Rahim. So I'm Muhammad Nur Arif from class 5 AKH. So I got question case 2. So for question A, first for question A, it asks to find the distance between A and B. So in this case, the question didn't give the clue about the time, so we assume that the time is equals to 0. So first thing first, we substitute the time equals to 0 to the displacement function. For example, for this question, the displacement function available for P and Q. So if we substitute, we will get this. For function P, if we substitute, we will get P equals to 10. While for function Q, if we substitute 0, we will get negative 12. So in order to find the distance between A and B, we need to use the number line method. We need to add the both number. So for negative 12, we need to assume it's positive because we need to find distance. So let me explain about this. So if the particle moves to the right, which means it's positive, while if the particle is negative and move to the left, it will become negative. To find the distance, we need to add both displacement lah. So we will get the distance between A and B is equals to 22 meter. Question B, first thing first, we need to equate the displacement function of P and Q like this. So the question give the function P and Q. So first we need to equate them. So it will be like this. Then we need to do the next is we must form a quadratic function. So that we need to balance both displacement function and equate it to 0 like this. I equate it to 0. Okay, so after that we factorize the quadratic function to find the time. So the time is this. The time is this. Okay. Since time cannot be negative, so the best answer we will choose t equals to 2. So the time is equals to 2. Okay, next for question C. When the question want a total distance travel, we need to find the displacement when the particle start, turn, and end. So the first thing we need to find is displacement when particles start to move. Since the question didn't give the total of time, so we assume that time is equal to 0. When time is equal to 0, the displacement also becomes 0. Next, we need to find the displacement when particle turn. So when the particle turn, the velocity will also become 0. So the clue is velocity is equal to 0. What we need to do now, we need to differentiate the displacement function to form the velocity function. So we will get 8 minus 16t. Okay, since the clue given is velocity is equal to 0, we can equate the velocity function to 0, which is this. 8 minus 16t equals to 0. So it will make our life easier and we're able to find the time based on the velocity function. So we need to make the t as a solar subject, like this. So to find the displacement of turning point, we just substitute t equals to 1 over 2 to the displacement function. So the answer will be s equals to 12. Okay. After that, we need to find the displacement at the end point. The question at the previous question, it said that time is equals to 2. So we need to substitute this to the displacement function. So we will get this, negative 6. After we have all the points, starting point, turning, and ending point, we need to make a number line method to make to find the total distance. So at the starting point, starting point to turning point is equals to 12. At the turning point to the ending is equals to 18. At 12 plus 6 equals to 18. So the clue is that the particle start to move at 10 meter. So we will need to take the total distance from the particles started to moving, because the particle start to move at 10 meter. So we need to subtract 12 meter, which is the total distance from fixed point to turning point, with 10 meter. To find the total distance when the particles start to move to the turning point. The last thing is we just need to add all the distance to find the total. So the total distance is 6 plus 12 plus 2 equals to 20 meter.